Hello everyone. In this video, I will discuss the properties of determinant. So, the first property of determinant is reflection property, which is the value of a determinant remains unaltered, means unchanged, by interchanging its rows and columns. So, whenever you interchange rows into columns, that is, suppose you have a matrix. If you transpose the matrix and if you find the determinant value of the matrix A and also the transpose matrix A, determinant of the transpose matrix A, then the value will remain unchanged. So let us take one example. Select you have a matrix A, B, C, D. Now, so your A dash will be, so convert this row into column. So here will be A. So this is nothing but a transpose of the matrix capital A. Now find the determinant value of A. Here, if you find the determinant value A, B, C, D, so here will be AD minus BC. Again here A dash will be AC BD, that is determinant of A dash is here equal to AD minus BC. So this value in both cases, that is for that of A and that of A dash, is same. So that means whenever you interchange rows into columns, then the value of the determinant remains unchanged. So this is the property 1, which is known as reflection property. Now move to the second property, which is known as switching property. If any two rows or columns of a determinant are interchanged, then the sign of determinant changes. That is, whenever you change one row or one column, then there will change of sign in the value of the determinant. Suppose in a certain determinant, the value of the determinant is 6 and you are changing any two rows, say first or second row you are changing, and then the determinant value will change. That is, there will be one negative sign in the determinant. That is, the answer of the determinant will be minus of 6. So in this way, if you change any row or column, then the value of the determinant changes. So this is your property 2. Let us consider one example for property 2. Say your delta is, that is determinant 2, 3, 4, 1. So value of the determinant will be 2 minus 12, which is minus 10. Now I am changing rows. I am changing this row, second row into first into second. This is known as interchanging of rows. So right here 4, 1 and here 2, 3. So here will be 12 minus 2 equal to 10. Now see the sign. So in the original determinant, the value was minus 10. And after changing the first two rows, the value is 10. So there is a change of sign in the value, but the absolute value will be same in case of whenever you change the rows or columns, any two rows or columns. So this is the property 2. Now move to property 3. Here, if two rows or columns of a determinant are identical, then its value is same. case of determinant, any two rows or columns are same. That is, all elements are same. So the determinant value should be 0. Or if any two rows have multiple, that is, one row is multiple of other row, in that case also determinant value is 0. So consider you have delta, and so if you change any two rows, suppose delta is one determinant and I am changing those rows which are identical. So we know that whenever you change any two rows or columns, there will be negative sign before the determinant. So suppose your original determinant is delta. So if you change the identical rows, so there will be one negative sign in the original determinant. So now, so here delta dash plus delta is 0. But we know that the delta dash and delta are same. So that means 2 delta is 0. So delta equal to 0. So that means whenever there is any two rows or two columns which are identical, the value of the determinant will be 0. Let us take one example. Let you have delta 2 by 2. So here 10 minus 10 value is 0. So that means if you expand the value, or if you expand the determinant value, then you will get the answer 0. So this is for 2 by 2. So let us take another 3 by 3 determinant in which you have two rows or columns identical. Say delta equal to, say 2, 3, 1. Here is 1, 2, 3. Here is 2, 3, 1. Now here, the first and third row is identical. So now find the determinant value. I am expanding along this row. So here will be 2. 2 into here will be 2, 3, 3, 1 minus 3. So 1, 3, 2, 1. 1. So 1, 2, 2, 3. So expanding along the first row. So find the value here. So here will be 2 minus 9. 1 minus 6. 3 minus 4. 2 minus 7. Here is minus 5. Here is minus 1, which is minus 14 plus 15 minus 1 equal to 0. So in this way, whenever any two identical row having the determinant will be implies that the determinant value is 0. Or even if there is a multiple, suppose here is 4, 6, 2. So this row is multiple of the first row. So here this is 2 times of the first row. In that case, the value of the determinant will be same again 0. So this is another important property that whenever any row is scalar multiple of the other row, then the value of the determinant is 0. So this is same for the column. That is, if any column is scalar multiple of the other column, the determinant value is 0. Now the property 4. Here, scalar multiplication property. In this property, if each element of a row or column of a determinant is multiplied by a scalar k, then its value gets multiplied by the scalar k. That is, whenever you multiply any row or column by any scalar, then the value of the determinant is multiplied by that scalar. Take an example, say your delta is ABCD. So here this determinant value will be AD minus BC. Now make a determinant, say delta dash, multiplied by the first row by K. So here will be KA, KB, and keep the second row as it is. So now find the value of this determinant. So here will be KD minus KBC equal to, take K common, so AD minus BC. So now this is equal to K. So this was the value of delta. So that means whenever you multiply any row of a determinant or column of a determinant by some scalar, then the value of the original determinant is multiplied by k times. Now the property 5 is known as sum property. The property is as follows: if sum of all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. So it is better to take one example to understand this property. Suppose here 3 by 3 matrix, A1 alpha, A1 plus alpha, A2 plus alpha, A3 plus alpha, A1, B1, B2, B3, then C1, C2, C3. Now, according to this property, here in the first row, in every element, there is a constant alpha. So that means if sum or all elements of a row or column determined are expressed as sum of two or more terms. Sum of two or more terms. So here, sum of one term is there. In every element, in the first row, alpha is there. So we can express this determinant into two determinants. So since here is a single constant, we can write A1, B1, C1, taking the first elements here A2, B2, C2, here A3, B3, C3, plus, now take the second from first row, then here B1, C1, here alpha, B2, C2, here alpha, B3 and C. So in this way you can split a determinant if some or more elements have in the row or column, then you can split the determinant into different determinants. Now take another example to understand this property. So let us take one example which is nothing but the application of this property. Suppose you have given to evaluate the determinant. Say in the first row you have ABC, in the second row you have, say, twice x, B plus twice y, C plus twice z, In the third row you have x, y, z, and you have to find the determinant value. So one way is that you can expand directly and find the value. But whenever it is given in the question that without expanding, so you can't do directly. So you have to use property. So now we can divide this determinant into two determinant as follows. So here will be AX and BBY, CCZ plus again here A 2XX, here B 2YY, here C 2Z. Now since this two row is identical, so the value is 0 plus. Now in the second row we have 2 in every element, so you can take common 2 to write the rest element. Again here these two rows are identical, means that this value of this determinant is 0. So 0 plus 0, which is 0, that is this value, that is determinant value is 0. So you can use the property to solve different problems related to determinant by using sum property. Now we'll move to the next property. Property 6, which is invariance property. In this property, if to each element of any row or column of a determinant, the equivalent multiples of corresponding elements of other row or column are added, then the value of determinant remains the same. Symbolically, you can write that if you change, say, Ri row, we are changing Ri row by Ri plus some constant alpha into Rj, or if you change column, say Ci, change this to Ci plus, that is, if you change Ci column to by Ci plus alpha Cj, then the value of the determinant remains same. So let you have delta a 3 by 3 determinant A1, A2, A3, then B1, B2, B3, C1, C2, C3. Now applying R1 implies R1 plus alpha into R3. That is, each element of third row is first multiplied by the constant alpha, then added to the first row. So that is alpha 1 plus, that is A1 plus alpha C1, A2 plus alpha C2, A3 plus alpha C3 will be the first row, and the remaining element should be same. Now if you find the value of this determinant and this determinant, the value will be same. Now let us take another example. Say you have delta equal to 2, 4, 6, 1, and another determinant delta 1 by applying R1 implies R1 plus 2 into R. So that is, you have to multiply the second row by 2, and then you have to add with the first row. So if you multiply, so 12 plus 2, that is 14. So here will be 2 plus 4, that is 6. And here will be 6. Now the value of this determinant is 2 minus 24, which is minus 22, and value of this determinant is 14 minus 36, which is equal to minus 22. So value remains changed. So value remains unchanged whenever you do this operation with the determinant. But in case of 3 by 3 determinant, you can do maximum 2 operations at a time. Okay. So this is the property 6. So in this video, I have discussed about 6 properties of determinant. Hope you enjoyed this video. Please subscribe my channel and press the bell icon to get more updates. Thank you for watching this video.